We are going to put 3.2 into two different sections. So 3.2, we're just going to cover the basics of variation on part one, and then part two, we'll get into some more rules and interpretations. So 3.2, it does say that it's one of the most important sections in the book. So it's talking about variation. And remember, variation is the shape, the spread of the data. So the basic concept of variation, well, we are going to look at three different kinds of variation. So range is the first one, which we've learned about range before. Standard deviation. And variance. So these are ways to represent the variation. So the word vary means differences. So we're looking at the differences within the data. So range is easily found by just doing max minus the min. It really isn't that useful, other than what's the maximum value, what's the minimum, what's the difference between them. We don't use that one very often. Standard deviation is what we're actually going to use quite a bit. If you watched the crash course number 4, it talked about variation and standard deviation and how it was found. It's basically the difference between the value that you have and your mean value. You're finding that difference. You're always comparing it back to the mean. So let's remember what our symbols are. So X bar, what is that? The mean. What is just X? It's just a data value. And N, it's how many pieces of data we have. So we'll call that the sample size. And we're going to learn two new ones today. So little s, lowercase s, is your standard deviation. And I'm going to refer to standard deviation sometimes as a SD or just S. And then sigma, so this is a kind of like a cursive O, lowercase cursive O. Or if you look at it sideways, looks kind of like a Q if it's turned on side. And so this is the population standard deviation. So little s is actually sample. I forgot to put sample on there. So it's our sample standard deviation. So these are the two formulas. So it has the summation of a data value minus the mean. You square it. You add all those values up. So you're going to have to find the difference between all of the data values in the mean, square them, and then add them. Then divide by your sample set or sample size minus 1. And then this other one, it just seems like a crazy mess right there. But I'm going to show you how to do it. It's useful to measure the variation. You want to measure how much the data values deviate away from the mean. So that's the, deviate from the mean, standard deviation. The value is usually positive. It is 0 only when all the data values are the exact same number, which is very rare. But your standard deviation would be 0 if all of your data values are the exact same. Larger values of S indicate greater amounts of variation. So whenever you're looking at data, it depends on what you're looking for, but you want that value to be very small. And then that means that your sample set aligns pretty well with your mean. The standard deviation can dramatically change with outliers. So remember that word resistant. So this is not resistant to outliers. Outliers greatly affect your standard deviation. Whenever you talk about your standard deviation, you can also say the unit with it. So the standard deviation is 5 feet. So the X values vary by 5 feet to the mean. All right, so we are going to actually find the standard deviation of a sample set. This is the same sample set that we've been working with on the eruptions of the geyser at Yellowstone National Park. So step 1, calculate the mean. Step 2, subtract the mean from all the individual values, and that's to find your deviation list. Square the difference, which will produce a positive number. Add up all those squareds, and then divide by our sample size minus 1. Then find the square root. Quite a few steps. So we just have the 12 values that we've been using. So n equals 12 here. So what is the range? So to find the range, we would take our maximum minus the min. So our max is 98 the max. Yeah. So 98 minus 65 is 33. And this is in minutes. So I'm going to put the unit with that as well. So all the range really tells you is how far the max is from the min. So let's find the mean. Do y'all remember the mean from previous? Let's see. What is it? Mm-hmm. And we found it. We found it on one of those first pages. 91.25. Let's go ahead and write that. Minutes. So let's find out how far away each of these data values is from the mean. So you're going to subtract. Go ahead and fill in this table by subtracting. So I'm going to take 98 and subtract it from our mean. So 6.75. So we're going to fill this in. So go ahead and do that. And then you're also going to square it. You can do these at the same time. I would go ahead and subtract them, square it, write it down. And what I had said in the last lesson is do not round until the very end. So you need to write down all of those numbers. Okay, so I'm going to give you some time to fill in the table. And I would try to line up my decimals just for organization.
music without commercials. This is the message on Sirius XM.
Good thing our set only includes 12. Imagine if we had 500. That would be awful. Okay, so hopefully you have this filled out, your table. So let's look at our formula or our instructions. So compute the mean. We did that. Subtract and square. So we did 1 through 3. Number 4 says add all the squares obtained from step 3, which gives us the summation. So remember the little like summation Z kind of looking thing? So we need to add all these guys up. Go ahead and do that. Be careful with your fingers. Promise this isn't torture. Or is it cruel and unusual punishment? You can check with your table and see if y'all got the same number.
I did.
Oh, good. All right, y'all ready to reveal? Did y'all get the same thing at your table? Oh no. Did y'all get the same thing? That's good. Oh no. All right. Catherine, what'd y'all get?
862.25.
Yes, that's what I got too.
I got the middle number, so.
Oh, you added the middle ones? Whoops. Yeah, we don't care about those.
Teachers, partners, and interruption. I need freshmen, last names ending, I believe.
Sorry for that interruption. All right, so we have this. So we're going to plug it into our formula. So we still have the square root. This is our summation, which we got there. So 862.25 over, what is n minus 1? N is 12, so that's 11. All right. So this value we can round to one more place than our original data. So we're going to round to the 10th place. Oh, I guess I could put this in a fraction. There we go. So that'll be 8.9. So the standard deviation is 8.9, and we got to use the units, so minutes. Did the outlier greatly affect that? Because look at the majority of this. How far away are they really? Look at these. They're actually really close. So that outlier greatly affected it. Let's do it without the outlier. So what can we do? We can just take this, subtract that from it. Okay, we're not gonna have to do all that work again. So 862.25 minus 689.0625. So this is going to be 173.1875. Take the square root of, and then we're going to divide. We no longer have 12 because we took one away. So now we have 10 on the bottom. .2 minutes. So wow, that's really a big change. So just taking out that one outlier made it where it's half. All right, let's go to the next page. All right, I'm not going to torture you. This is the second formula. We're not going to do it. We just did the one formula. Let's go ahead and look at page 14. So I'm going to save you right now, and I'm going to tell you the calculator can find our standard deviation for us. Hallelujah. Okay, so enter the data into L1. Go to stat, calc, do that one variable statistics. The sample standard deviation is SX. Population is sigma X. And then we'll talk about variance in a little bit. So let's go to our stat, edit. I still have mine in my L1. Do you still have yours in L1 from the last lesson? If you don't, go ahead and put it in. So it's this data in L1.
See, mine asks me to make a name for it.
Okay, which you can.
It
You
won't
can.
let me do anything unless I have a name.
Have you cleared the memory on your calculator?
I just do X.
Mm-mm. Just use my calculator for now, and I'll show you after I finish the lesson. So let's go, once we have it in L1, go stat, calc, one var statistics, one variable statistics. And then the list is L1. That's where we put our data. Now go down to calculate. And then it gives us standard deviation, which if we round it, see the SX. And then it also gives us a population standard deviation. It gives us the N, min, max, all that. All right, so we're not doing that. The formula for the population standard deviation is sigma is summation of x minus mu. So y'all remember what mu is? It's your population mean. And n is your population. Little n, lowercase n was your sample size. Uppercase is your population size. The population standard deviation divides by uppercase N, the number of data values in the entire population. The sample standard deviation divides by N minus 1 independent data values. Otherwise, you will underestimate the value of the population standard deviation and variance. The advantage to the first formula is, the reason why I use that is because it's talking about an average. Think about, you sum up everything and then you divide by how many there are, except we take one out. We didn't even do the second one. Let's talk about variance. Variance is found by squaring the standard deviation. So the notation for the sample variance is S squared. Notation for population variance is sigma squared. The sample variance S squared is said to be an unbiased estimator of the population. So unbiased estimator means that these two will target each other rather than under or overestimating. So these two should be very, very close to each other, to the same values. So you see that word tend to target the value. That means that they fall in line, they're about the same. So to find our sample variance for the intervals of the eruptions, you would take this, if we use what we rounded, remember we're not supposed to round whenever we actually find a value. We don't round until the very end. So in order to find standard deviation squared, we're going to have to use all of it, yeah. And then we can round it at the end with our final value. So our sample variance, 8.85360.738, and then square it. So we can round this value now. So one more than the original data, so 78.4. And this value is actually squared. So it's going to be minutes squared. So in that crash course, it's talked about having the units squared. And we really use standard deviation because that becomes back to your original units, like minutes. So that's what the disadvantage is. The units of variance are different from the units of the original data set. Okay, so that is the end of part 1. So part 2, we will interpret and understand standard deviation.